using the latest Visual Studio 7.1, which got released, I think, yesterday or today. And we're going to pick up kind of where we left off with our heroes, talking about C#10 and what's coming up later, or C#9, and we'll talk about how we've moved from C#9 to C#10 and the kind of things we've been doing since then. So I've got a small program that we start with. It introduces a record, which is something like a class, but it implements a number of methods for you. So records, we say, want to have value-based equality. So normally if you declare a class, two objects are equal if and only if, or two variables are equal if and only if they refer to the exact same object in memory. With a record, it's value-based equality. So two record types are equal if they are their properties are the same. Okay, so we can kind of demonstrate this here. I'm creating a person. His name's Scott Hunter. Then I'm going to make another person where I'm going to effectively, this with expression makes a copy that's modified with some of its properties. So it copies person and then says, when you do that, change the last name from Hunter to Hanselman and give me a new one. So now I've got two different people with different names. I can now make a third object that's the original person, and I'm going to use that same with expression to say, well, go back to the original name. And now just writing out, are these two, this original person and the one we created first, are they equal? And because this is a record, if we run it right now, and I'll pop the console over to the screen, we can see that both of those two records are equal. Now, if I change this to a class, my withers stop working, but they would no longer be equal because now equality is measured by having the exact same type. Well, starting with C#11, we like the features that we added for classes, for records, which are based on classes. I said, the same kind of adding equals, not equal, get hash code, and so on are useful for structs as well. So now let's say you can declare a record by saying record class, and that distinguishes it to be a class type rather than a struct. So record class and record are exactly the same. We allow you to place class there, so if you want, you can distinguish between the two of them. But what you can also do in C#10 now is you can say this is a struct. So now this person object doesn't get allocated on the heap. It's going to be in line as an array, just like any other struct that you would ever work with. So now as a struct, we're going to get effectively the exact same behavior. And again, equals returns true because we're using this value-based equality for a struct type. Now, once we did this and we put this in place and we said, we can do records that are structs, we said, there's some really useful stuff that falls out of that will be great on other types that people create, like these with expressions. It is a non-destructive copy. And starting with, I think, C#8, you could write a deconstruct method that enabled with expressions on class types. Well, now, since structs already know how to copy themselves, suppose this is just a struct and not a record, I now have with expressions work just with regular structs. Okay. So record structs and structs are fairly similar, although if you note now, the one thing that does not happen is equality doesn't get implemented. The overloaded equals operator. So for that, it would have to be a struct. This back. Okay, great. So we've got a struct there. Now, once we do that, let's leave this a struct. And we'll just remove this. Oh, once we find, we've got withers, we've got a few other types that we've created that with expressions could be useful with. Let's suppose I just remove person here. And now you can see the person here is now an anonymous type. Okay, so it's just a new anonymous type thing with properties for first name and last name. And with expressions work now with anonymous types as well. So when the compiler generates an anonymous type, it will create with expressions. So you can use with expressions with anything pulled out from link queries, anything you're doing, like if accessing entity framework and you want to change it. Well, that's going to now create a new object, changing some of the properties. So the idea behind this is what we've now done is we've expanded the types that you can work with. So the way I kind of think of this is we've introduced tuples. Those are just, I want to store a couple things together. And now the grow up story for tuples. Now suddenly I want properties, I want some kind of behavior, but it's still mostly storing data. I can either make it a record struct if I want stack-based storage. If I decide I really do want this on the heap as it keeps growing, maybe there's some inheritance and so on, I'll make a record class. And maybe it's only used inside one assembly and I don't really want to have to declare something. I don't want some of the other record-like features. I can make it an anonymous type. Those are your kind of grow up stories from tuples as you start to prototype, build some things, and decide you want more features. So the big reason about adding some of these things that fall out of creating record structs and adding them to anonymous types and so on is not so much that we think everybody's going to use them in all those places all the time. But what it means is as you're writing your program and you're not sure what type to create, it's not quite as critical to get it right the first time. There's more commonality between all the different ways you can speak of creating a type. And by doing that, what it means is if you started with a tuple and you find you need something else, you can change it to a struct. Oh, I now need an inheritance hierarchy. Let's change it to a record class and so on. And you can keep kind of extending those data types without ever hitting a wall where it's suddenly, I'm now going to make a breaking change that's going to be really bad for everybody who's consumed this type. So that's where that part really comes from. Now we've got record structs. We've got a number of other improvements. So then as we work with structs, what we will also find is we end up, well, there's some other things that structs are really different from classes that in order to make them easier to use and easy to work with, well, let's expand the kinds of things you can do with structs. So if we look here at our person, which is now a struct, well, structs you've never been able to declare a default constructor. Well, why shouldn't you be able to do that? So we're going to say, we can even declare a default parameterless constructor. And inside that, we can say first name equals John. And last name is, no, we don't know who that is. So we've now declared this parameterless constructor. Now, this is a very big change in philosophy that introduces something that has some interesting ramifications. So now, if we walk all the way back up here, and I were to go var p1 as a person, and if we say that's equals the default, and person p2 equals new person. Now, those two are going to be different in that, let's just do a console.writeLine p1.firstName and a console.writeLine first name. Here's the first one a little bit. We'll use our string interpolation here More clear exactly what's different. If we run it as we've now written it, you can see that when we made it by declaring it to be the default, that first name is null. And when I declared it as a new person, our constructor gets called and first name is set to John. Now this is really important because of how structs are used in different ways. If you think about creating an array of some structure type, ever since C#1, everything in that array is all set to zeros or the default value. So we wanted to preserve that behavior, that because structs aren't always allocated by using new, if you just declare a struct, it's always initialized to 0. So that behavior is still the default behavior. So if you declare any kind of a struct and you initialize it by saying it has the default value or default of person, that will always be all zeros. If you declare it using the constructor, that will call a default constructor if one exists. If not, it's going to give you the zeros, because this would still be legal even if I removed this constructor. Okay. Now, if we can do a constructor, why can't we just do field initializers? Declare it this way. Then I shouldn't need the constructor. Okay. Now, this would have compiled with C# 10.0, but as of 17.1, we introduced a breaking change, which is why I'm getting the squiggles here. Because this resulted in some really confusing behavior. What we did in C# 10.0 is, if you had initializers but did not declare a default constructor, well, we didn't run the initializers. And the reason we didn't was that would be a breaking change from the default behavior that was there before, and you didn't write a constructor. So what we're doing now is, if you follow this pattern, you are going to need to declare an empty parameterless constructor and actually write that code, and then that will call the field initializers. It would also be called for any other constructors that you happen to write. So in this instance, if I wrote one that took just first name or just last name, that would still call the field initializers to initialize them before the struct is initialized. Okay. So any questions on that involving the things that we've been doing with structs? Okay. The next section of this has to do a lot with things that we're doing to remove clutter, make programs hopefully easier to understand, and make it easier to do the right common things without having to do a lot of extra typing or a lot of extra macros or who knows what. So as our project starts to grow, well, we're going to want to move this into another place. So let's refactor this. We're going to move this type to another file. So now I've got it in person.cs. That's awesome. I want to do a little bit more refactoring. Let's put this type in a namespace. So let's call this our models namespace. Okay, awesome. But this introduces our clutter. I've now had to indent everything 4 spaces. And if you look on GitHub, if you really want to analyze just a whole lot of code, what you'll find is a good 96 to 97% of all files introduce one namespace, have 1 or more types in it, and then end. So let's give you an alternative syntax. So if we just put that semicolon there, notice the Visual Studio figured out what I was doing and ripped out the open and close brackets and gave me my 4 horizontal spaces back. So what happens now is I've introduced a file scope namespace. So everything from this line on down will be in the models namespace. Okay, cool. Now, so far so good. So now let's go back over into our programs file. We already had this. It already introduced, added our models. Life is good. As our program grows, what we're going to find is we're going to end up with like all of the same namespaces used just about everywhere. So let's go make this better. So I've got a file here that has a whole bunch of usings in it. These would be the things like I just generally commonly use in just about all of the files on my project. So I'm going to say they are now global using statements. Now what happens is when this project gets compiled, that using statement will effectively be added at the top of every single file in my project. I now just have, I don't have to declare these anymore. If I slide over into my program.cs, you can see these are now grayed out. I could now apply one of my refactorings and say, let's just remove those unnecessary usings. I can do the same thing here. Wow, now I've just got a namespace and I got the stuff I wrote. I like that, right? It's now getting my code a little bit shorter, a little bit cleaner to concentrate on what's actually written here rather than go through everything. So once we've done this, I don't want to have to write this stuff by hand every time. The build system has a really good idea of just what kinds of things we're building. What are we working with? We know what kind of project it is. So let's now edit this project file. And let's say, I don't really want to type all that stuff. But because this is an executable, it's .NET 6.0, the compiler will know what I want to do. So if I say implicit usings and I want to enable it, now what's going to happen, excuse me, is I can just remove this file completely as soon as I save this and do a build. Because the compiler now says, okay, or the build system now says, this is an executable, it's using .NET 6, so it's a console application. So here's the set of global usings I'm going to add to this project. Just implicitly, just basically dump an include file into your project. If this were an ASP.NET project, which would be known by using a different target framework, there would be a different set of global usings that would go in. If it were a Xamarin project, once again, it has a different TFM. Instead of .NET 6.0, I think it would be the Xamarin.macOS 6.0, I think, or whichever TFM would specify whether it's Xamarin, Android, or so on. It would include those specific usings. Now, in my usings, well, I wanted to add my models because I'm probably going to use that everywhere anyway. Do that inside my project. I can in the same property group or in a different item group. And I would normally do it in a different item group just for a little bit of clarity. I can now say using, I'm going to say include and model. I think I said I used plural in mine. So that now says when the SDK runs .NET Build or when you build from Visual Studio, when it puts out all the implicit usings, it's going to add this one as well. So now if I look in usings, let's just do a build so it figures out which ones were there. Now after that, come on you. Go ahead, let's rebuild the whole thing. IntelliSense should be picking those up and I should be able to just remove all those. Okay. There we can remove that one because it comes in globally. Here, I should just be able to remove this file completely because everything now is in my in my main project, and off we go. Except that I have to add that one back in. We'll put that in the project as well. In the file. What this does is it means you can now use a lot of simpler syntax for what other elements you've had in, or what other libraries you rely on, what things get added into your project, and so on. So I'd like to get kind of just a read of the room here. Any comments on this? We've had some feedback that people really, really dislike it. A lot of feedback that people like it. Some feedback that people like it, but don't like that the templates have changed and that this is on by default in new projects. Yeah.
I don't like that I need to edit like XML project. Is there like a GUI for that? Where do I go? Tools project or something project properties?
It's a good question. I am not sure.
I'm like super visual person. Is there anything that's there? I'm just curious.
That one I am not certain of.
Yeah, my feeling is that it's probably like too new for us old geezers. So
Okay.
I wonder if there's a new project and people know about it, they probably will use it.
Mm-hmm.
The old projects, I'm not sure.
So at the moment, I don't see one. I will ask as to whether or not there is a UI to add something as an implicit global using. But that is a good question. Any others?
For me, it's odd. When I view it, it's just odd because everything's not nested like it used to be. That's me. Okay.
If we are using static, just curious, and have two different objects with the same method.
If you're using static and two different objects have the same method, if you put both of them in scope, that would be ambiguous, and you would have to add the namespace or the class type on one of them.
Thank you.
Yep.
Is there any cost to having all the using statements included in every file?
Yes, sort of. So yes, and this is where there was a lot of discussion of exactly which implicit usings to add. And this is really an implementation detail, and it is a build system performance concern. So unless you're building a big library or a big project, and by big, I'm talking something like the size of the runtime or the size of Roslyn, some 20,000 source files, you likely won't run into this. But what the compiler has to do is when you add a using statement, it has to build a symbol table of all of the types that are, and methods, public methods, and so on that are in that namespace. Okay. So there is a bit of an impact in terms of how the compiler builds its symbols. It is not something you'll notice for anything but absolutely huge projects. But it is a good reason not to just add the entire VCL into your global usings. That would probably be bad. Okay.
Okay, thank you.
Yep. All right. And with that, we'll head off into lambdas. So the other thing that we've done is we started to really look at, why sometimes we've had to like really specify everything when you create a lambda expression. Something like, say this one here. I've had to say, deal with all the types here. Why, why do I have to declare this as func of string and int? Compilers should be able to figure this out. I mean, this is obviously going to return an int. This is obviously a string. So, okay, fine. Let's just make this var because we like that kind of stuff. So what will happen here is, if you look, this is still now, it is a func of int string, and that will work just fine. Now, sometimes there isn't enough information. So this is one of those features that you can use some of the time, but maybe not always. Whoops. If I delete the type string from this argument, now the compiler isn't sure what type S is, because it could be multiple different types. It's just, it can't know for certain. So you would either have to specify, func of, if you specify func of string int, then I don't need to specify the parameter type there. If I specify the parameter type, well, then I might not need to specify the delegate type. Okay, it's also legal now to say this delegate type, we're going to assign it to different kinds of things. Maybe make this an object because I'm using it in some ways where I need to pass something around just as object. Could make it a delegate because all funcs and actions derive from delegate. If I'm doing something with writing a link provider or something like that, I could make this an expression. I'm pretty sure I'm going to have to add a using there. There we go. And what the compiler now does is it says, since you wanted this to be an expression and you said it did, it's going to determine what kind of function it is. It's a func of string int. And then that's the kind of expression you're going to get back. Okay. Now, we can do the same kind of things with lambdas in a lot of ways, or with return types. If we look here, this returns bool or object. Now, if I try to change this to func, or this to a var, now this doesn't work. And the reason is, the compiler says that's an int, that's a string. I can't figure out the common type. I don't know what you're returning. Okay, so there we have to keep that as an explicit type so that you can declare the best common type for it. Okay. The other thing we can start to do now is console.read, because that only has one overload. I can now declare that as var. The compiler will figure out exactly what method is meant, even though it's the method group there, just by giving it read. But if I try to do it on action of string or on console.write, it won't, because there are several overloads there. So the delegate type can't be inferred. So effectively what we've done is, in a number of different places where you use lambdas, you may not need to specify the parameter types, the return types, or the expression types, or the func or action types. You can often, the compiler can often infer them, and when it can, it will use those types. If you specify certain things, it will create a delegate of a slightly different type to match what you declared. Okay.
I have a question.
Yes.
So if you're relying on inferring, based on a single overload, and you add an overload later,
Mhm.
this could break.
Yes,
Code.
that would be a breaking change.
Okay.
So if you were going to add overloads, it would depend on whether or not you're using, it would be a compile time breaking change. So it would probably be pretty quick for developers to spot. It would also be binary compatible unless you removed an overload.
Got it.
Yep.
Thank you.
Now, the last thing we're going to do, we're going to do one last thing and then a preview feature in C# 11. We're going to do something kind of interesting. Okay, so let's say we had something like this. Debug.assert, it's now writing out the time, and it's going to call some expensive calculation in order to create the string. All right. Now, in this particular instance, because debug.assert is a conditional method, it just goes away in release mode. But let's say this was some other logging library and you wanted to be able to switch it at runtime using some set of switches. So this wouldn't be completely removed during compile time. Under C# 9 and below, what happens here when you have this string interpolation expression is that all the holes, the arguments have to get evaluated. So you have to run, get the date time, and you have to run that expensive calculation to get those arguments, and then you format the string. And in the case of a lot of log libraries, you're going to format the string only to throw it away, because these were all things that you're only going to log in debug mode or in certain things when you turn something on in the portal for application insights to get more detail because you're trying to debug something, and otherwise it's just taking all kinds of time. All right. So instead now, what we can do is, what happens is we're going to get a type called a string builder here on an interpolated string handler. And what the interpolated string handler can do, where do I have this code? Is what it's going to do is it is going to be able to actually, it appends things during runtime in order, but only if it gets called or if it's going to get used. So you can configure a string handler to on your debug assert to say, I'm just not even going to use this thing at all. I'm just not even going to use it. Okay. As long as the type that comes back for a string is going to somehow support it. So what you can end up doing is you can end up writing and the runtime has already done this, has written a interpolated string handler that's now attached to a lot of the log methods and to string builder that says, okay, so if this is called in a context where it's going to get thrown away anyway, just don't even build any of the arguments. Don't build the string. Don't do anything with it at all. Okay. And if you look here, what string builder.append does, if you see what it doesn't take, it doesn't actually take that string or that object from args. Its parameter is a ref string builder interpolated string handler. Okay, so that's going to then call one of these new handlers that appends to the string only when it's needed. So what are you going to see from this? Several APIs have changed signature in a way that still compiles, because the compiler is now picking a different overload. A lot of your apps, if they were doing a lot of logging, are going to run faster when logging is not enabled. That is one of the things that got some very significant performance improvements in ASP.NET Core. This is a lot of things that Stephen Tobe worked pretty extensively on in terms of diagnosing where these things were being built, proposing an API that enables the runtime to say, okay, at runtime, let's figure out if we even need to build any of these things. And if so, don't build anything. The only way you could end up with any kind of bad effects from this is if in one of these evaluations, you introduce side effects. So if you did a calculation here or incremented some variable and then, and made it something like this, where mock coding here, but if there were we're sitting here and then every time you called it, you incremented some state and changed state, then you might see that not work the same. So far, we haven't had any reports of that. So we don't think that kind of idiom was used much, but that was the one thing that you may see in different places when people show up with something that might not work correctly. Any questions here? Okay. And then finally, I'm going to give a preview of how we're going to continue to do some things in C#11 that is going to make it easier to write more concise code. So even though, let's take this method right here, even though we've turned on nullable reference types, some code out there may pass a null here. So what most of our production code, if we wrote it well, would say if args equal null, throw new argument exception for null or for args. Some people write it this way. Some people would write it this way. Some people got really ingenious and said something like a discard equals args unless args is null, and then we'll throw that and try to save one line of code. So varying degrees of clarity here. So my own personal choice is usually this. And of course, our coding standard says I need to do that. And now this has only one argument, but a lot of our methods have 2, 3, 4, 5 arguments. So pretty soon the first page of a method is doing nothing but null checks. So let's give a very, very convenient syntax to say, I would like the compiler to inject code that is going to do a null check at runtime and throw an argument null exception with the name of the argument. And this should, if I really want to be spiffy, I would do it this way. And let's give you a really convenient syntax to do that. So we introduce the bang bang operator, and this goes away. And now if you see right now, because I'm in 17.1, this I'm getting a compiler error, and in order to fix it, I am going to need to come on, you should be there. Give me the refactoring. Here we go. No, it's not. It's going to make me edit this by hand. So I am going to need to introduce lang version as preview. And as soon as I do that, this should now compile. There we go. So in C#11, we're introducing the bang bang operator, which will introduce an automatic null check. Now this will only work in a type that could possibly be null. So if I go down here where bool is a value type, add the same bang bang, and now I'm going to get an error. But notice my red squigglies are under the variable, and it says, look, this is a value type. There's no way it can be null. Well, okay, maybe this API really was supposed to be a question mark bool, and then that should work. That should work, buddy. Yeah. And now, yeah. And now if you put it on a nullable value type, you'll get a warning that says, this is, did you really mean to do this? And part of that is, if you said it was a nullable type, well, didn't that mean it was legal to pass null? Same thing would happen here. If I go object array question mark to make that a nullable array, I now get like, dude, what are you doing? You should not be annotating a type that you said could be null. Don't do that. You introduce both the question mark to say I really, really wanted this to be null. It's possible it's null. And if you put then the bang bang operator, it's going to say, dude, you said this could be null, and now you're saying it can't. So what are you doing? So a few different things we like about this feature. It lets you write more concise code. We think it will lead people to add null checks more often because it doesn't obscure the rest of your method. And it helps you get the semantics right, in that this will give you warnings if you try to check something that shouldn't be null or can't be null anyway, or downright errors if you try to check something that can't be null, and warnings if you try to null check something that you explicitly said could be null. Additions like this bang bang operator seem to me to take more brevity for less clarity and ability to infer looking at it. So this is a real interesting thing that we really think about a lot. I'm shortening the question a little bit. This is feedback that we've gotten so far. And here's something that we're really looking at in terms of this and in terms of features like this. And yeah, it's a valid opinion to say the last couple releases have trended toward a lot of code conciseness, and approachability is comprised, and curious about other viewpoints. When we go about designing a feature like this, there's something that we really, really work on and try to think about. What we want to do is introduce a set of characters or a set of operators that stand out when you first see them, and then slowly fade into the background after you get used to them. And the idea is that as people adopt them, they become familiar, and then it reads very naturally. This is object args and throw if null. Okay, but you have to get used to it to get to that point. And what we do hope is that we don't want to go too far one way or the other. You know, we discussed making this an attribute so that it would be something like throw if null, right, on that argument. And we felt that if you looked at signatures that had multiple arguments, that could get really verbose and really obscure what you're trying to read of the code, which is what does this method actually do. We like it for a couple different reasons. A concern we have, and one of the things we're trying to do to make correct practices easier, is the number of places where developers, if they don't have super strong code review rules and so on, forget parameter checking or leave it off because I'm sure this will never be null. It shouldn't be null. It can result in a lot of bugs later. And bugs that actually cause data corruption and so on because you blithely keep going when an argument was null and it really shouldn't be. So our hope is that by having a smaller, simpler syntax for a very common use case, that this slowly becomes something people like to adopt. I will point out that this is a preview feature right now. So the only way you can turn it on is in preview. And we are actively soliciting feedback. So everything I've just said is basically my own opinion more than, you know, an official team statement. So I am curious to hear what others think. Patrick, thank you for that. What you wrote down is, and yes, it's true. There's a big difference between the C# and JavaScript bang bang meanings. That is definitely true. Right. Yep.
I think I like the bang bang
Mhm.
more than I like hiding all the usings, because I think
Okay.
hiding all the usings falls on the other side of what Patrick brought up. But that
Yep.
would just be my opinion.
Okay. That is true too. We've also had a little, some people concerned about that. And that one, I think one of the main things is really trying to keep that list really short to the, I'm pretty sure you probably put this using in every single file you have. And there is a concern we have about that one too, a little bit, in that it's the global usings is a language feature. And that also even got to the point where it's a little bit more difficult to reason about code just by looking at the text of a file. You kind of now need the whole project. And the implicit usings take it even a step farther, and that you kind of need to know what things were added implicitly. So yeah, that's definitely something that's still being considered, and that's why implicit usings is still optional. If you just, in your project file, it's going to be off by default. And if you remove that key, even from a new project, the implicit usings won't be added at all.
Did there used to be a global usings anyways, a file somewhere that the compiler would pick up?
No. That was way back in C++ to do precompiled headers. That was way old.
All right, so I'm old.
Me too.
There was that concept in like MVC and Blazor, but that's separate from
Yeah.
the compiler.
Yep. So.
But
And
I do like that Patrick brought it up, and I do like that, the team is sort of thinking about these things as they make these changes, right? Like, I think it's important to, as we, as the language evolves, to make it, as the conciseness to also weigh that against what's it like for someone to actually learn the language and start fresh with it. I think it's important to balance those.
I would agree, and there's a balance there. That's where we've held also in an interesting way. We've had really good feedback from new developers on top level statements, and it is people who have used C# for years who are going, wait, no, I don't like this. But especially younger developers whose first programming experience was JavaScript, just seeing this window of just code that starts at the beginning and goes through is just incredibly natural for them. This whole, what's this namespace? What's this class program, static void main stuff? So there's definitely debates on how do we balance this in different ways. Okay. And any other questions? All righty. Well, thank you very much, and I will turn it back over to Jason.
Oh, great. Thank you very much, Bill. So I will upload this to the YouTube channel, and if you don't follow me, I'm on Twitter at Haley Jason. I will tweet out the URL for this recording so you can forward it to your friends who couldn't make it tonight. Thank you all for joining. Have a good night.
Yep. Thank you, and I'll get an answer to Olga's question and post that on Twitter as well once I get that.
Awesome. Thank you very much.
All righty. Thank you.
Bye, everybody.
Bye all.
Thank you.